Yeah, excellent.
Yes.
Okay, many thanks. Okay, it's okay, you can hear me well?
Yes.
Yeah, okay, cool.
Yes.
Okay, so thanks. So welcome to all of you. Good morning, good afternoon. Thanks a lot for joining this joint SNS 6G-IA and 5G-ACIA online webinar. So this webinar is the second one that we organized jointly. There was the first one that was organized in May this year and focused on trials and pilot. So really focused on industry 4.0 and manufacturing. We organized the second webinar focused on ISAC and JCAS. So very also interesting and very promising development. So my name is Didier Bourse. In case you don't know me, I'm working for Nokia and involved with colleagues from SNS and 6G-IA on many different activities. So, and I'm really happy that we can co-organize this very promising webinar. So I'm going on the, we have a packed agenda, as you can see on the slide. So when we were working on both sides, so with SNS 6G-IA colleagues and 5G-ACIA colleagues, we were deciding to take this orientation to organize the webinar this way. So there will be an introduction, welcome from Raffaele and Afif from both sides. And then we organize in 3 separate sessions, so you can see also the timing. So basically a first session on use cases and requirements. So the idea is really to develop synergies between the different, between the communities and also globally with all participants in this webinar. So to check what is addressed and let's say investigated by the SNS project. So we have 6 projects from SNS that will be presenting and contributing today. There are more projects that are addressing Industry 4.0, and there are more projects that are addressing ISAC JCAS. But today there will be specific highlights from the colleagues you see displayed in the agenda. So I will let's say chair the first session on use case and requirement, and we will have then Hanwen from Working Group 1 in 5G-ACIA will also bring the ACIA perspective on the use case and requirement. And you may know we have pushed from our SNS side colleagues to clearly, if not already done, before this webinar, to look at the very interesting white paper that was published by 5G-ACIA end of last year. Okay. Then 5-minute Q&A. Don't hesitate to use the chat. Again, for those of you who join now, the session is recorded, the video and the material will be available. So we are also supported by the co-op coordination support action in the SNS to organize this webinar and this event. And thanks also to the 5G-ACIA colleagues for this extremely good organization of this joint webinars. Then going to the agenda, so we have a little bit more time for the session 2, where we will look at ISAC and JCAS research innovation, validation, challenges. So again, we have on one hand the SNS project, providing some highlight on their research work. So you see, as displayed on the screen, it will be chaired by Costas, this session. And then we will have Atte from Working Group 3, with the Working Group 3 chairman in 5G-ACIA, who will also bring the latest perspective, latest update on what is developed, what is let's say investigated from 5G-ACIA side. And then we have also 5-minute Q&A. So you see, basically, according to the agenda, we know it's packed. We know we will have to be a strong timekeeper in order to be sure, but there will be a lot of, I encourage you to use the chat because some questions may be also answered live by chat or in the 5-minute Q&A, or alternatively offline if you like also to continue and to pursue the exchange. Then we have the session 3, also very important for ISAC and JCAS, standardization and impact. Where do we stand as of today? So again, both SNS and 5G-ACIA perspective. So Alex will chair this session 3 for the part of 6G-IA. And you have also a set of projects. And then we will have from 5G-ACIA the perspective presented by Michael with Working Group 1 chair, and bring latest perspective and update, reminding also that 5G-ACIA is a worldwide organization in terms of membership. And then we will come to the conclusion, last thought with Raffaele and Afif, concluding and opening the perspective for both on ISAC and JCAS, and also for next interaction, possible synergies between SNS 6G-IA and 5G-ACIA in 2026 plus, and there are a lot of opportunities ahead. So I don't want to take more time. I'm passing directly, I will stop sharing this one. I'm passing the hand, and I again welcome all of you, and I'm passing the hand now directly for the introduction. I stop sharing, and I think it's you, Costas, who now takes the hand, correct? To share, to share, and we will hear both Raffaele and Afif. Yeah.
Correct. So I'm sharing slides for Raffaele.
Yeah.
You can go ahead.
Yes, thank you. Thank you, Didier, for organizing this workshop. Very interesting. Welcome from 6G-IA board, of which I'm a vice chair and I'm delegated for vertical engagement activities. So going to the next slide, who we are. 6G-IA is a private counterpart of the European Commission in Smart Networks and Services Joint Undertaking, and we are the follow-up of the 5G-AI, which was the private part of the EC and the 5G PPP. So 5G PPP and the SNS-JU are two legal instruments foreseen by the Treaty of the Function of the European Union, and they allow for co-investment in research by public and private industry. Next slide. Okay, 6G-IA has experienced a strong increase in membership since April 22. Now we have more than 400 members in our association, which include main vendors, European operators, verticals, top industries, and research centers, and a significant number of SMEs. If you see the composition of the membership distribution, you see that we have a majority of research center. The industry is represented by 11% of this membership, but expresses the majority of the board, since 6G-IA is totally industry driven according to our statute. Next slide. This is the portfolio of membership in vertical sectors that we have been able to build in all those years. As you see, 5G-ACIA is our partner for smart manufacturing, but we have also partners for the automotive, media, cybersecurity, transportation, space, agriculture, and public safety spaces. So we have MOU in places with all those associations with which we collaborate in each vertical sector. Next slide. So the scope of this webinar is to strengthen the collaboration with 5G-ACIA for the smart manufacturing sector, exchange information on key achievements and findings, elaborate on how beyond 5G and 6G can offer solutions to smart industries, and follow up the first workshop which took place a couple of months ago. Thank you and welcome.
Okay, you can go ahead. This is directly to Afif.
Yes, good morning and thanks, and really warm welcome from my side. I'm the new 5G-ACIA General Chair, and I'm happy here basically to participate and welcome all of you on this common workshop with the 6G-IA. And what I would like to give you a short overview of 5G-ACIA. Some of you basically know about 5G-ACIA, but it doesn't harm, to remind you. Our mission ultimately is to make 5G in verticals industry, special manufacturing process happening. And we have been working together, especially OT and ICT industries, already from 2018. And contributing first, basically trying to impact the standards, and then to try to build a common language and try to do common test bed together. And it has been a long journey involving, of course, academia and looking not only on the short term, but also long term. But still, nonetheless, ultimately is to make 5G, the industrial 5G ecosystem thrives. Especially attracting new end users and try to convince them that 5G will be a solution for them, will resolve most of the use cases. This is in a nutshell. And we have a broad, I would say, kind of, these are the main categories. And if you move on to the next slides, you will see a list of our members. global ones and from different, basically, you know, MNOs, suppliers, OT players, test companies, academia, institutions, etc. And we have been, I would say, this is some unique alliance, and we work really very closely to each other. And of course, with a common goal. Even, you know, there are competitors like every alliance, but we put that on the side or having in mind the common goal. And if you move on to the next slide, maybe I would like to show you, as Rafael have shown, we at 5G-ACIA, of course, we collaborate broadly with many alliances. Many of them here, they are in different aspects. They cover certification on standards, on 5G, on 6G, and 6G-IA, of course, is one of them. And for today's webinar, the main focus, of course, will be on ISAC, integrated sensing and communication. Even though this has been perceived as a long-term, we had activity in 5G-ACIA. And if you can move on to the next slide, will show where exactly in our structure we have had these activities. We will continue on that. I will not go into it on the structures. You can go to our webpage and find more details. But in particular, if you zoom in to working group 1, and this is the next slide, where you will find we had released a white paper, this is mentioned by Didier, on ISAC for connected industrial use case automation. And we have looked at the use cases which are relevant from industry perspective in a factory where, for example, you know, where sensing, I don't know, a piles or stock, etc., could be very beneficial, or to avoid accidents in a factory or refinery. And then, as a continuation, we are going to have, or we just approved another activity actually a couple of weeks ago in Frankfurt, and this is more tilted towards sensing assisted positioning and working group 3. And here, that's the reason, of course, we have today Michel Bar from Siemens, who's leading working group 1, and as well Ate Lassi Mesrali from Nokia. In addition to that, I would like to mention those 2 work items has been led by Huawei. So this is a short introduction. I hope you will enjoy the workshop today, and looking forward basically to hear more the details from the speakers. Thank you.
Many thanks, Raffaele and Afif, for this excellent introduction. So thanks. We will find you. You will come back when we will have the conclusion. So thanks. The proposal is that we now move to the first session. So I will share the slide. I see that in between we have received more participants. So just let me know if you can see full screen. Is it okay? You can see full screen? Yeah.
Yes.
I guess so. Yeah. Thanks for the feedback. So let's move. So you have understood. We go until quarter to 11, and we will address, let's say, both use case and requirements. So we will have 6 project presentations. So I'm covering the part from 6G-IA, and then we will have Han Wen will be covering during this session the part from 5G-ACIA. Okay. So if I go, I just want to quickly, in 4 slides, set the scene and explain you what is SNS at the program level, you know, programmatic view. Where do we stand? So basically, well, I think most of you are very familiar because you are expert in 6G. So you know, let's say, the enhanced capabilities and the new capabilities. So you see in blue and you see in green the two color code. And then, as you can see, of course, in the new capability, you have this ISAC, this integrated sensing and communication. And there is a lot of work, indeed, inside SNS done by the different projects. And as you may know, it's covering, let's say, from research to innovation to up to trials and pilots. Okay, so we have many different activities also related to the phase, to the different phases. There are 3 phases in SNS. So this is we see different maturity level also on the work that is happening there. So you see in the bullet points a list of specific important point under the category of ISAC, and I guess there should be, let's say, a synchronized common understanding here during this webinar about the challenges. So here you can say, wow, it's nice. So I'd like to congratulate again, each time I congratulate Costas with, among others, chairing the technology board, congratulating all the projects. So we have today 79 projects that have been contracted, some already ended, okay, so in SNS. So 79, and we expect 21 additional projects to be contracted next year, beginning of next year. So it means that we will top 100 projects. Okay, so it's a huge number of projects working, and the idea of the joint undertaking SNS is to make all these projects work together. So basically, we have a lot of intra SNS at the program level work, and we are very keen to organize these specific webinars with 5G-ACIA to make between communities, let's say, further boost of the innovation and future impact. So you see, this is a list of projects. When you look basically, and when we make an extract, if you see on the right this icon for integrated sensing, this is an interactive map. In case you don't know it, I really encourage you. You can hyperclick, and you see it's very well done. And you find 22 projects that are, and you see the list of projects, and then you can visit, and so on and so forth. So there are 22 projects over the 79 projects that are addressing ISAC and JCAS. Okay, so don't hesitate to visit. Then we have also a very powerful tool. We discussed that in the context of let's say specific interaction between SNS 6G-IA and 5G-ACIA colleagues, and for instance in Nuremberg and also in Helsinki and in Frankfurt. So this is the vertical engagement tracker. That is a powerful tool where we also take into account all the activities that are related to the vertical and spanning again from let's say low TRL up to pilot, so up to TRL 7, and you can filter by project, by let's say country, by specific vertical, and then it's an illustration here on this slide. There are today still work in progress, of course, but 344 inputs in SNS, and if you filter for industry 4.0 manufacturing, you find 61, and you find the related fish, let's say specific like this fish for XR or DALI, and then you have more information and you can visit and so on and so forth. It's also very interesting to access to information on what is happening technically in SNS. And if I go, and then I will stop there, in terms of recent state of the art. So clearly, our intention is to go beyond the state of the art and see where do we stand today. Okay, so as you can see listed on this slide, again, this excellent white paper from 5G-ACIA colleagues, then in the UCNC and 6G Summit, and we will come back later in the conclusion to this, there are also a lot of activities. It's a good point to meet and cross-fertilize and exchange. There were a workshop, session, tutorial, then the ETSI, because of course the ETSI development, and there was this webinar, the 5G America. Some of you certainly also had a chance to read a very interesting too in July, and then recently again your series of webinars in 5G-ACIA, very interesting. One in July addressing in particular ISAC in this specific webinar. So that's it from my side. So just a kind of 360, you see, I hope it will give you some, raise some interest from your side in case you're not so familiar to look for more information. Now let's move. So we have the 6 projects in one by one. So the proposal, and I will have to be the timekeeper, sorry about that, but we pass directly to Sebastian for multi-X. So Sebastian, you're online, it's okay?
Yes,
I can go to the next slide. Yes, please, go ahead. Yeah, please.
Thank you very much. So multi-X started in January. What we have done in the work package around use case and requirements is that we looked at both ETSI and 3GPP use cases, 5G advanced as well as 6G, and trying to identify, is there anything that we are doing uniquely? And we did indeed. So we came up with 8 use cases. The list you can see here is the one that are currently written up. So I believe that there are 1, 2, 3, 4, 5, 6. We have 8 in total. You see location as in does the use case play in the indoor or outdoor, and you see also technologies being used. And that's really what I would like to convey here, is that those use cases, they are not only focusing on cellular sensing, They're also heavily what the World Economic Forum now tossed at one of the top 10 technology trends, which is collaborative sensing, meaning you really allow a mobile network to not only replace existing sensors, it's quite the opposite. You want to leverage and utilize all the sensing capabilities of what 3GPP calls non-3GPP sensors to actually leverage. So you can see under technology, all use cases cover this collaborative sensing angle. And if you can go to the next slide, please. So we are essentially following what both the 6G-IA ISAC as well as 3GPP SE1 is doing. We are consolidating both functional as well as performance requirements. As this deliverable is only due by the end of November, I can only share with you at the moment the performance requirements that are already consolidated. So that is what you will find in the group report 1 of the ISG as well as in 3GPP SE1, the consolidated table. So you see our performance requirements when it comes to typical sensing KPIs, and you see the notation of 3GPP in brackets, which is our numbers that are, it's hard to identify any sort of normative work that has been already published. So they're our numbers that we believe we want to achieve. And you can see the range there basically of all the use cases. And with that, I would like to hand over the next one.
Many thanks. So crystal clear. And then we will listen also to you in the next slot. So thanks, Sebastian. Now let's go to Kostas. So Kostas, you're online.
Yes.
Also. Yeah. So
hello.
I can go. So with welcome. So please, go ahead, please.
Okay, thank you. My name is Kostas Maliatzis from University of Aegean and University of Piraeus in Greece. Today I present ISA6G. As a project, we go beyond integrated sensing and communication concepts and expand integration to include computation and energy transfer, enabling a truly unified radio paradigm. This vision is tightly aligned with SNS vision for energy efficiency, spectrum reuse, and multifunctionality for 6G. So the ISA6G use cases share a basic concept, a common basic concept, the aerial corridors. These corridors are envisioned as communication and sensing and energy highways for drones and UAVs to support various services and applications. So the figure here shows the ISA6G system model, including UAVs acting as user equipment, network radio units, relays, and more. Ground UAVs that communicate and sense through 6G, sensing targets, harvesting nodes, reconfigurable antennas and surfaces, and more. Among these lines, ISA6G has defined a set of use cases that connect the ISA6G architecture with real applications. So first, we have a generic use case, physical layer, so ISAC in 6G cell-free environment. Then we have UAV corridors, aerial sensing communication paths for logistics, surveillance, or mobility. Safety enhancements, so collision avoidance, cooperative localization, mission-critical services, agricultural and industrial IoT for large-scale monitoring and energy autonomous sensors, connected cooperative autonomous mobility, so vehicle-to-everything enabled SICAM through ISAC, and energy harvesting for sustainable IoT through integrated wireless power transfer. To the next slide. So at the top here, we see the scheduler, the ISA6G scheduler, which coordinates all functions jointly under the unified controller, performing joint coordination and optimization across the different objectives. And in the right table, we quantify the target KPIs for ISA6G use cases across 5 basic categories. We have sensing, location, performance, and terms of orientation, precision, velocity, and range accuracy, communication metrics, mainly latency, capacity, service availability, and energy and security. Based on the investigated use case, different requirements have emerged, and you can see on the left side a diagram showing the methodological backbone that we use to derive the performance KPIs, representing the complexity of the optimization frameworks that we have built. There were competing functions, understate information, available resources, and tools. You play significant role to the outcome. So that was all from me.
Thanks a lot.
Thank you.
Thanks a lot, Kostas. Very good, very great. So let's move now. Thanks to Dan. So I don't see Dan. Dan, are you online? Because I don't know, Kostas and Alex, if you see Dan online for the timing or someone from Ecoinet. If not, my proposal is that we may pass to, no, I don't see. So we may pass to Madhu, in this case, to Isaac, and try to see in between if Dan has some issue to connect. So my proposal, so it's Ecoinet, so we come back. Let's move to Madhu. Madhu, you are online. Hi, so you're online.
Yeah.
Yeah, good.
Hello.
Good.
Yeah. So I'm Madhu from. Can you hear? I hope you can hear me. This
Yeah,
is
yeah,
Orange
yeah,
in France. Yeah.
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 Welcome, welcome.
Yeah. And so this is about DISAC is the distributed ISAC. So distributed not in just in terms of the normal multi-static sensing, but over a wide area and over a large scale of time. I won't go into the sort of it won't be exactly like what say for instance printed. It's that there are many use cases that are available. We have seen some of them. So what we've decided to do is to focus on something that we can demonstrate the benefits of the DISAC architecture. The use case would highlight that. And of course, it also has to have a business potential and a demonstration potential. Yeah, you can move on to the next slide here. Hello.
Yeah.
Yeah, right. So, this involves both. I mean, if you look to the right side of the figure, there's both the indoor and outdoor environment. In this case, it's vehicle coming in from an indoor environment and then going to an outdoor environment, let's say for dinner and finding a parking space, for instance. And so when I mentioned about the distributed ISAC, one of the things is that what's typically called the sensing service area, that the area that we need to cover by the sensors evolves dynamically because it's from the perspective of the moving car, right? So that's one aspect. There's multimodality, which I mentioned also, so I'm not going to that. The other sort of interesting aspect in DISAC is the multimodal fusion with the use of semantics in the middle block. So we used the semantics to do this multimodal fusion, and the trajectory computation. One of the things that is of interest on the trajectory computation box is that it could be either local to the vehicle and process completely in the vehicle, with of course the help from the infrastructure, or a completely infrastructure approach. So one of the features of DISAC is that we have distributed sensing, both at the local nodes, at the edge, and at the core. Yeah, so these are sort of some of the features that one can highlight from DISAC. Yeah. Thank you.
Many thanks, Madhu. Also very interesting. Many thanks. I propose that we go to the next one. So Isat with the 6G musical. So welcome, Isat. So I saw you're also online. Huh? It's okay.
Thank you very much, and a pleasure to be here. Next slide, please, Didier. So I'm Izzat Darwaze. I'm a professor of communications at University College London. 6G Musical is a project of many partners. Many of them are research, or several of us are research labs, and the work we are doing is effectively to define more scenarios really than use cases, although we have defined use cases. And these scenarios are what we expect to be part of the key operation and standards of what will become the 6G or ISAC in 6G. And we also work on defining the architecture or setting architectures that could be used within the standard of 6G as architectures for comms and sensing. The scenarios we look at are 3 different scenarios and their variants, and they're mainly either based on the use of the radar functionality and the comms functionality at the same time. And they are either based on using monostatic sensing with one transmit and receive located at the same position, bistatic sensing, the one at the bottom of the slide, or multistatic sensing, where the sensing is done by a set of base stations. We define high-level architectures for these that will merge both the sensing function, which is new architecture, and the comms function, which is part of the existing 5G architecture that will be modified appropriately for 6G. And our colleagues at Ericsson looked extensively at the design of signals according to standards and looking at the effect of adding the sensing functionality to the comms signal. Next slide, please, Didier.
Yep.
We also looked at scenarios and use cases where either the sensing function is applied to connected objects, so a UE moving around, or unconnected objects, and that is the sensing of objects within the general environment. There is no time to go through any of these details, but I can tell you the two main conclusions that we have got up until now is that the use of the comm signals as they are now in 5G and as they are being proposed for 6G for sensing would require some modification of the signals, but minimal modification. So signals fitting within the standards will be easy and straightforward. And the second conclusion that we have reached is that to effect sensing of both connected and unconnected objects with accuracies, localization accuracies in the centimeter level range without adding complexity to the system requires modification of the synchronization architecture, specifically when we have multistatic sensing. And I'll mention a little bit about this in the next presentation.
In the next session. Thanks a lot. It's very interesting too.
In the next
Thanks.
session. Thank you.
Thanks, and thanks also all of you for keeping the time. So let's move to the next slide. Oops, 6G reference. So Eric, yeah, please. I saw you online also. So welcome for 6G reference presentation.
Yes, thank you. So I'm representing 6G reference. I'm from Twente University. I'm the technical manager of the 6G reference projects, where we cooperate with several partners like IMEC and Ericsson and ETH University in Switzerland. Next slide, please. Our focus is mainly on hardware, low TRL level hardware innovations, and the use scenario we are focusing on is a factory hall scenario, and to a lesser degree an urban square scenario. So clearly on communication, but then we are working on a new band, the 15 gigahertz band, where we have 400 megahertz bandwidth, and distributed cell-free MIMO systems with a lot of radio units, where we think it's no longer practical to have everything connected to fibers. So the assumption is that there is a densified network with about 25 meters grid distance between the radio units. In the right picture you see the radio units, and that there is only in the center one node which has fiber access, and the rest of the nodes are on the grid. And we focus not only on ISAC, but also on the full duplex communication, where the full duplex can support the monostatic radar functionality also well, because of the self-interference isolation that you need. And also the over-the-air synchronization, which is very crucial then. Next slide, please. So we are very much focused on the hardware. We develop IC hardware chips and radio array, phased array antenna solutions. And some specifics that we work on are filtering antenna with improving self-interference isolation for full duplex and self-interference cancellation techniques. And then the ISAC goals are 0.5 meter and 0.5 meter per second that we target. But we try to do it with very simple, minimalistic hardware, not too big arrays. And also we focus on the timing synchronization, and the requirements are mentioned here. So below 1 part per billion frequency synchronization, so that we can also support multistatic sensing. Below 100 frames per second jitter, and also accurate time stamping. And the holy grail would be to do actually coherent transmission, where we would need to go to even picosecond alignment, which is clearly extremely difficult. And we're kind of exploring the limits of what we can do with hardware and how far we can push it.
Yeah. Thanks, indeed. Very challenging. Thanks also a lot, Eric, for this. So my proposal now, I don't see Dan. So my proposal is that we move now to Hanwen. And thanks again to all the colleagues. I see that there are some questions on the chat. Don't hesitate if you are directly, let's say, if the question is raised to you, your project, to answer. So I stop sharing. And then Hanwen, I see that you're online. So you are really welcome to share and to start. Yeah, thanks. So you are mute. I think you know you're mute.
Sorry.
No, okay. Welcome.
Hello, everyone. So very nice meeting you. Okay. Can you see my screen now?
Yeah, not presentation mode, but we can see it. Yeah.
Okay, so now and can you see my presentation now?
Yeah, but this is in the mode where we see the next slide, and this is yeah.
Okay, so
Still in the yeah, it's still your mode. Yeah,
I see. Okay, so I will turn off that presentation mode, second screen only. Sorry.
No issue. So again, don't hesitate.
No?
Don't hesitate to.
How about?
Yeah, for the timing we don't see Manuel.
Yeah. Okay. So entire screen. Okay. Entire screen share. Okay.
Yeah.
Okay. So can you see now?
And now we can see exactly. Yeah, we can see it. Yeah.
Yep.
Thanks. Please.
Okay.
Please.
Please. Okay.
Yeah,
Okay. Hi everyone. So So my name is Hanwen Cao, and I am leading the Wireless System Innovation Lab here in Huawei's Munich Research Center. So I am now speaking from the 5G-ACIA side because I was rapporteuring a work item on the ISAC technologies, especially on the use cases. Yeah, so let's go straight into the content. So we have worked on the use cases requirements of ISAC, particularly from the connected industries and automation businesses. This is an outline of my talk. So I thought it's a bit too long for our today's agenda, so I try to make it more compact and more concise. Okay, so I see every expert now in this webinar should know this famous picture that the evolution of the 5G technologies is taking into account 3 new features, including the integrated AI and communications and ubiquitous connectivity, and particularly the integrated sensing and communication, ISAC, from the, let's say, vision of the ITU for the IMT 2030 framework. Yeah. And of course, just a brief overview of ISAC, that we think that ISAC has a unique benefits, that this leveraging the single infrastructure, the same infrastructure to providing both communication and sensing services with unified network infrastructure, with unified spectrum resource and unified standard framework. And there are many applications, many use cases, and I just saw from all the, let's say, SNS projects, a lot of use cases, and also there are some also sorts from our 5G-ACIA site, ranging from object human detections, environment reconstruction, imaging, micro movement sensing, object size measurement, and also to unify the sensing and the communication localizations. The integrated network and coordination. So this have a huge potential that we can build up a sensing network which is integrated, leveraging the multi-static, bistatic, monostatic, and multi-view sensings, and also to introduce the integration of non-3GPP sensings, so some kind of multimodality integrations, and it's already highly coordinated and with high precision. Yeah. So we think that there could be 3 levels of integrations ranging from application level, spectrum level, and ultimate the full integration levels from the low layer up to the application level. Yeah. The state of play. So we 5G-ACIA, in our work, we have investigated some works from the research, including also 6G SNS programs, and also a lot of other research projects from over the world. And also active research organizations such as 6G IMT 2030 6G Promotion Group and IEEE ComSoc. And also, of course, some of the good projects have been aforementioned by the colleagues from SNS has been also investigated partially. Yeah. Also from the standardization aspect, so we have active activities from ETSI side. They have SG and ISAC. They investigate use cases, channel modeling, architecture, and also the earlier terahertz ISG has also some work related to the sensing using the wireless network. And very importantly, 3GPP. So in the release 19, they have already a lot of good work, including the use case definitions, the 32 use cases defined, some initial service requirements definitions, and also the channel modeling in the round 1. I think they have almost finished. Yeah. And so in release 20, so a lot of new work is going on, especially we see that in the, let's say, the big use case technical report, there are 20 ISAC use cases already defined, and also also from system aspect, study from the radio access network and also security aspects. There are already some work established and also under planning. Also, of course, from our let's say pairing wireless technology IEEE, they have Wi-Fi sensing task group, which is investigating on a similar topic, even longer than let's say 3GPP technologies. Yeah. Okay. So 5G is focused on ISAC. Yeah. So with 5G-ACIA, we have established a work item since September 2023, investigating the ISAC use cases for industries. And we got great support from many companies, ranging from the, let's say, ICT companies, and also from the operation technology companies. And with Huawei and me personally, taking the role of rapporteur for this work item. The white paper has already been published at the beginning of this year, and which is openly for download. So if you're interested, you can go to 5G-ACIA website, and you will find this use case white paper very easily. In between, we also have some active liaison interactions with ETSI, ISG, ISAC, ISG terahertz, and also 3GPP. Yeah. From our work, we think that there are several major benefits of ISAC for the industrial automations. So, and unified infrastructures. So this is very important. We unify the sensing infrastructure and the communication infrastructures. So this is would be a direct benefit of cost optimization. Yeah. We envision the ISAC could provide even higher sensing performances, leveraging on the multi-node, multi-static, multi-modality, and sensings. And also, for the radio frequency sensings, it can leverage on even wider range of spectrum for sensing, which is a good thing for improving the sensing resolutions, accuracy, etc. Yeah. It's have a unique suitabilities for the harsh environment because our technologies are well suited for environments such as dusty, heat, high humidity, and low light conditions. And a unified infrastructure can provide a unified, let's say, security functionalities. We can also leveraging on the ever evolving, let's say, security mechanisms from the 3GPP technologies to guarantee our data securities. And for the primarily the RF sensing by ISAC, it's also a good mean for protect privacies because compared with other optical or audio sensing technologies, RF sensing can somehow minimize the privacy concerns by its physical nature. Yeah. Okay, so we have, let's say, concluded several, let's say, most interested application areas of ISAC for industries. So, which includes detect and tracking of ground, even area vehicles and human in the industrial environment, tracking and size measurement of the goods for the productions, and human-machine and machine-machine collaborations. Safety and health at work, which is also crucially important for protecting our human beings for industries. Environmental mappings to, let's say, to get a better overview of the complex industrial environment for mapping and also for navigations. Also, the radio sensing can provide us some good means of predictive maintenance to guarantee let's say, the good conditions of machineries and pipe such type of infrastructures in industrial environments. Quality inspection, so the RF sensings have also some unique benefits for, let's say, inspect the quality of the outcomes of productions. Yeah, and also to improve localization and communications. So let's say to integrate sensing and with communication together and explore the mutual benefits. Yeah. So based on the contributions of our members in 5G-ACIA, so we have 5 use cases. The first one is the gesture recognitions for industry environment. So these use cases, we think that the ISAC can provide the unique benefits in industries. So, for example, in industrial environments, so the human workers, they may subject to some conditions like wearing protection gloves, helmets, and there could be high noise. So this will make the conventional, let's say, human-machine interfaces not very useful. For example, some touch panels and also voice interfaces. And to use ISAC to sense human gestures can help the human workers to, let's say, precisely interpret their intentions to control the machineries using their body movements. Yeah. The second one is also the vibration monitoring for industrial environment. So the vibration is one of the biggest enemies in industrial environments. So let's say the abnormal vibrations can indicate some potential issues in the machineries, and we can leverage let's say the high sensitivity of Doppler effect of radio frequency sensings to capture these signals, and in order to guide our predictive maintenance. The third use case is also for stockpile monitoring. So let's say conventional stockpile monitoring technologies, they may struggle in harsh conditions, as aforementioned, such as dust, smoke, and low light environment. But with radio frequency sensing, so this can guarantee you, let's say, all day, all condition monitoring of stockpiles, which can be used for optimize the efficiencies of stockpile management. And for optimizing the flexible productions. So we think this is also another member's contribution. They think that the ISAC could be a good means to continuously monitor the movement of humans, of machines, AGVs, AMR, such things in industry environment. This is a good means for, let's say, optimize the efficiencies, to identify bottlenecks, and also to prevent potential accidents. This is a good means of increasing productivities, shorten lead times, and improve resource utilizations. The last use case is also very, very important. That is the hazard prevention for industry environment. So we think that ISAC, by integrating the, let's say, radio frequency sensing together with also other sensing technology together, can be able to protect the safety of human workers in the industrial environment, such as falls, collisions, and liquid gases. So it's let's say a vision of a larger picture of unifying the sensing to give a comprehensive protection of human workers in the industrial environment. Yeah. Okay, so the last part would be not the last part yet. So after this work item, so I also investigated how our use cases and be reflected in the new use case definition work in 3GPP and ACI, ETSI. So we see that the first use case is just recognitions. The industry environment is partially, let's say, reflected in one of the ETSI use cases, and also one of the new 3GPP use cases in the 22.870 technical report. Same. We also see that vibration monitoring has been also, let's say, have some, let's say, commonalities with also the use cases of micro deformation sensing for the ETSI, and also for infrastructure collapse monitoring in the 3GPP use cases. Use case 3, stockpile monitoring, is also somehow integrated in the use cases for high resolution topographical mapping and the use case environment object reconstructions from the 3GPP. Flexible production flows, and also we have the somehow reflected by the ETSI use cases on the real-time cyber physical system in the industrial work sites, and also 2 of the use cases from the 3GPP technical reports. And the hazard preventions also receive high attentions. There are 2 relevant use cases, let's say, to detect the health hazard and disease risk, and also to leverage sensing of ISAC for outdoor healthcare sensing and monitoring. So yeah, this is very encouraging. So we see that let's say most of the aspect 5G-ACIA are concerned about ISAC has been partially interpreted in the ongoing standardization work from ETSI and from 3GPP. Yeah. Okay. Last, I would like to see also some demonstration of some of the use cases, which is mainly done in my research lab. For example, in these cases, we can leverage on the high millimeter wave frequency band using the conventional OFDM QAM waveforms to create a high resolutions penetrative images of the object of sensing. Next one, we can leverage on the ISAC to detect the human locations, the location of objects, and also the postures of human and robots. And same way leveraging on the OFDM QAM waveforms. And we explore on the centimeter wave, let's say the alpha 3 frequency band for this test-based study. The last one is that we try to check the potential of leveraging the high, let's say, sensitivity of Doppler frequency shift of the radio signals to sense the gestures. As you can see here with some Doppler time feature, which is captured in the ISAC systems, we can use that to control the movement of robots. Yeah. So key takeaways from the talk is that we think ISAC is a very encouraging technologies. So they bring the sensing and communication together and create new businesses for our mobile network. So of course, this substantially work should still be done. So we are happy to see there are many research work, especially also from the SNS side. Many research projects are working on these technologies, yeah. And for industries, we think ISAC holds also considerable potential to advance efficiency, quality, flexibility, and safety, information security, and also cost effectiveness. The last is that when we think that when combined with let's say the ever fast evolving AI technologies, the integration of sensing and communication will be potentially unlock even great transformative potentials for the industrial. Yeah. So as also Aristotle has also envisioned 2,000 years ago, so the whole is greater than the sum of its part. So let's see how these integrations will bring us forward. So
thanks.
I'm excited about it.
Yeah.
Okay.
No, thanks a lot, Hanwen. Very comprehensive and very well. You started also to address some of the point on standardization with the mapping of the use cases, and we will come back on this in the slot 3. And
exactly,
it's very good. It's very good. Thanks. And again, I encourage. I think a lot of us have read already the 5G-ACIA white paper, and it's a very, very good reference material. So thanks for this. For the IC, we are okay in terms of timing. To call it a bit more time, but it's okay with the slot 2. I see question on the, there is a more general question, Jens. So I propose that we treat it also, some colleagues may like to cover by chat and bring feedback by chat directly. And this will be also the topic for session 2 and 3. So clearly we will take your point, Jens Bies, and we will reply to this live. My proposal, and thanks again, I exchanged with Dan. I think you have the material from Ecoinet, so you can check in the PowerPoint. But I propose that we go with Costas and Atto to the session number 2. Thanks again, very great. So clearly, we see the complementarity, the synergies, and the high interest of ISAC and JCAS. Costas, you take the hand for the session 2?
Yes, absolutely. Thanks so much, you, Didier, and all the speakers so far. So let me start sharing and officially start the session 2. So hopefully you can see my slides in full screen mode. In this session, we'll be discussing research and innovation and validation and respective challenges for ISAC and JCAS. So my name is Kostas Trichias. I have the pleasure of serving as the chairman of the SNS Technology Board, which is the body of the technical managers of all active SNS projects. From my side, just to paint a picture regarding validation efforts in the SNS JU, you can see on the bottom left graph an overview of the trial sites, test and trial sites across Europe that have been created and maintained and utilized by the SNS project. We have more than 120 tests and trials taking place in more than 25 European countries, with a very strong presence in South of Europe, but a very good spread across the entire European Union, which is very good to see that we have activities all over the continent. On the bottom right, you can see a snapshot of the key achievements that have been mentioned by the projects that are related to the ISAC and JCAS technology. So you can see that already from the ongoing projects, we have at least 15 key achievements from 9 SNS projects regarding ISAC and JCAS technology. A webpage will be soon launched on this, so you'll be able to get more information about what exactly its project has done and what their achievement in this area is. But let me not delay things any further and give the floor to the protagonist of today's webinar. So Sebastian, why don't we give the floor immediately back to you to talk to us about the validation challenges in multi-X.
Thank you very much. If you can go, yes, please. So multi-X at its heart has basically the term multi-X is the meaning of the project, meaning the aim is really to revolutionize the 3GPP radio access network in its design as well as operations. And the idea is to really allow the ability to fuse on the at least perception-ness level, the ability to perform sensing. So this impacts both the architecture within the RAN as well as the protocol stack. And needless to say that even though it's really the focus is on the RAN component, no RAN can work without a core network. So take this with a pinch of salt. That's the project is within the focusing so much on RAN, but indeed we are fully aware that we need also equally support from the core network side. Now, the multi-angle is essentially the focus point to get multi-sensors. So you saw this in the use case and requirements, any sort of sensors, not just sensing. The aim is to integrate this multi-static, so bistatic, monostatic, bistatic, multi-band, so supporting different bands from FR1, FR3, FR2, multi-technology also. So not only we're doing RF, it comes a bit to the sensor element, also any sort of technological enablers when it comes to sensing, just to mention camera, machine-to-machine camera, video feeds, there's this very nice MPEG works recently, LiDAR, radar, you name it. Also the ambition to address the sustainability goals of the United Nations and to really try to demonstrate, even though the project targets TL4, to really go into what is the societal impact the technology can have. And no doubts that the project will leverage AI to achieve the full potential of ISAC, which is indeed needed, in particular for the target object identification and classification. And a very strong aspect, of course, on the sustainability angle, given that ISAC is a new technology that will be added to the existing cellular network, meaning you need additional energy to achieve this, resources. And what we are essentially aiming for, yes, is two POCs, two scenarios, two locations, which is the at Siemens Lab and Phytonic, where we bring all the technology in those two labs and demonstrate the KPIs and KPIs we are after. Thanks.
Have you concluded?
Yeah, that's it. Yeah, sorry. Yes, yeah, sorry. Yeah.
Okay.
That's
okay.
Thank you.
Thank you so much. Right on time. Many thanks for your description. Let's move ahead to IC6G and Costas Manias. Costa, please, the floor is yours.
Yes. Hi again. So in this slides, we present some experimental and trial activities for IC6G. Here specifically, we cover the ISAC and UAV radio channel measurement campaigns and the modeling and characterization effort that we perform. So we investigate and modify some well-accepted radio channels in order to extend them for ISAC support. We have developed a Remax-based channel sounding and characterization process that it is also enriched with some learning features. We have developed three integrated three channel sounder setups for measurement campaigns that are performed in FR1 and FR2, focusing in UAV and specifically in ISAC characterization, mainly for quasi-monostatic and bistatic setups. And then we investigate ISAC channel modeling. Now, in the lower part, we highlight the prototype works for antennas, for intelligent antennas, for multi-purpose ISAC and wireless power transfer operation. We also, we also for the RIS development for FR2 communication and sensing, and the development of the IC6G radio unit with adaptive beamforming for joint sensing and communication operation. So if you can go to the next slide. The main activities here presented involve the joint communication sensing and energy transfer using waveforms, custom waveforms, based on
excuse me, Michael Nilsson, would you please mute yourself because you're interrupting the session? Costa, please go ahead.
Thank you. So the concept here is to do all this with the same waveform, same hardware, and the bin management schemes that are able to tackle these issues. Performance in the investigations for UAV-based links and their effect on network coverage, latency, and sensing were performed. And also we investigated the concept of the UAV corridors that are used to assist communications and sensing performance tasks. And the key steps here is the design of this OFDM-based physical frame that performs all these multifunctionalities, the integration of the IC6G antenna modules with the beamforming arrays and the RIS elements into real POCs, and the development of ISAC algorithms that are tuned for UAV and FR2 setups. And all these are going to be tested not only in the lab, but also in outdoor environments with proof of concepts that will be performed at Orange Romania test beds and at the IMEC 6G lab. So thank you.
Thank you very much, Costa. Right on time. Very interesting. Let's move ahead to Hui Chen from 6G-ISAC. Please, the floor is yours.
Hey, good morning, everyone. So my name is Hui Chen from Chalmers University of Technology. So I'm here to present our work on the 6G-ISAC project, which is distributed intelligent sensing and communication for 6G. So this project consists of partners from CEA, Nokia, Orange, AMS in France, Chalmers Richard in Sweden, TIM in Italy, and QA in Greece, and EC and Bosch in Germany. So we will mainly focus on our work package. So in this project, focus on the physical layer. So we aim to tightly integrate sensing and communications and focus on three aspects: the transmitter side, receiver side, and the sensing-aided communication. So the transmitter side, we need to design signals in time, frequency, and space that can serve dual purposes. So they are also enabling efficient representation of the sensing data. On the receiver side, we focus on the advanced signal processing to complete the task of positioning of connected device and the sensing of passive objects. So all the positioning and sensing results will be used to assist communication. So if you see the figure on the red bottom figure, it shows we have a pipeline. Starting from the transmitter and receiver selection, we design the signals and optimize them. From the received signal, we process it and get the sensing data and share it to other users or to the fusion centers, which will complete our task. Could we move to the next slides? And these slides, we split those physical layer solutions into three tasks. The first one is physical layer optimization and adaptive beamform shaping. And the second task is sensing, localization, and tracking of active and passive objects. And third task is sensing-aided communication. In each of those tasks, we provided one use case. So the case one is semantic-aware communication of sensing data. So in this case, the motivation is if we transmit all the communication data or sensing data from the transmitter to another, the data load is pretty high, and we will choose what to send and how to compress them in a semantic way. In the second use case, is joint localization, synchronization, and mapping via physical coherent distributed arrays. So this is under the scenario of using a distributed system. So there are several radio straps or other distributed access points, and we model the complicated environments and the channels in this scenario, also capture the reflection, scattering points, and to perform positioning and mapping the environment at the same time. The third case is sensing, location-aided dynamic handle management. So in here, we can predict when and where the object will be, and to perform handover in time. Yep, that's our short presentation of 6G ISAC, and thank you very much for your attention.
Thank you very much, Richard.
Thank you.
Very nice and on time. Let's move ahead to 6G Musical, and ISAC, please, the floor is yours.
Thank you very much. So it's me again. So effectively, just to remind you, what we're looking for are things to satisfy requirements of 6G when it comes to ISAC. And these are high-level accuracy, centimeter-level accuracy, and also minimizing energy and minimizing or optimizing energy and optimizing spectral use. And what we found is that we need a specific architecture, or we wanted to develop specific architecture that could allow these three things to happen at the same time. We have seen earlier in the presentation by Eric on 6G reference, the importance of developing specific sets of hardware and testing hardware to allow this. And that's what we're trying to do here. So we developed this architecture and we are building it all in hardware. The architecture itself is based on three techniques. One of them is the use of optical fibers and generation of radio over fiber signals that come from a highly stable source. It is this thing that you see at the top of the architecture. And this will generate signals that are highly stable with very low phase noise. These two things are very important for 1 centimeter level accuracy. And the only way to generate very low phase noise signals is to use highly stable optical signals. We use specialist equipment that is developed by one of the project partners, which is Menir in Switzerland. The overall architecture is based on the following. I'll try to do this in a minute now. We generate highly stable optical signals. We use the same optical signal to use an electrical equivalent to drive the electronic part of transmitters and also to generate the highly stable signals that will be transmitted on fibers and then distributed to base stations. The assumption is that there'll always be fiber in the ground, so distribution using fiber is not a problem. The signals then at the receivers, which are the devices that you see at the left-hand side of the remote units, the right-hand side, I'm sorry, of the figure, we beat the highly stable optical signal with the information that is being transmitted, the data information that's being transmitted, and the data information and the signal together will carry both information, so comm signals and sensing signals. And then these, once they are beaten together at the remote units, they can go on the antennas. We have got a set of base stations for multistatic sensing. There's an example of 3 of them there. And the main problem is that once you have fiber in the ground or when they have different lengths of fibers, synchronization becomes an issue because the fiber length effectively will change and will change dynamically, not just statically. So we have developed a technique of phase caching where we can guarantee that there's very small jitter and phase difference between the signals that are used across a set of remote units for sensing. And we're talking about femtosecond level of jitter, and we are talking about picosecond level of synchronization accuracy. Similar to what
you need to wrap up, please.
Okay, thank you very much. Just the last thing to say is that we have tested all of these in laboratory conditions, and we are getting the femtosecond level jitter and the picosecond level accuracy. That should lead us to centimeter level accuracy of positioning, whether we use any signal from sub 6 gigahertz up to the millimeter wave. Thank you, Kostas.
Okay,
I'm sorry.
Thank you very much. Very interesting. Then let's move ahead to our last project presentation from 6G reference and Mark. Mark, please, the floor is yours.
Hi everyone. Yes, hi everyone. So my name is Mark Baudin and I work with Eric on the 6G reference. So as Eric already presented before, the goal of 6G reference is to be able to reuse the same hardware for communication and sensing. And as for the communication part, the goal is to use OFDM. The idea is to see if you can do OFDM radar on the exact same hardware. And here, an important concept to understand in this ICAS system is that sensing and communication are done in 2 different time slots. So for example, 20% of the time we'll do sensing and 80% of the time we'll do communication. This means that when we do sensing, we don't have to carry any information. And so we can define the waveform as we want, which means that we can choose in advance what we'll put on each subcarrier. And that's very useful because in this case, we can, for example, do OFDM with a very low PAPR. So we can, for example, develop a OFDM waveform which have PAPR below 2 dB. And in addition, we can also add some technique in waveform design, such as specific phase rotation, designed to remove the impact of hardware non-idealities. So as we can see on this figure, we have the example of a range profile. So that's how the radar sees the world. And we see that at something like 13 meters, we have a reflection. But because of IQ imbalance, it's not visible on the blue range profile. If now we optimize the radar waveform, we can reduce a lot the range side lobe such that we achieve the red range profile. And so just by doing waveform optimization without changing the hardware, we are able to improve a lot the dynamic of the radar. And also important to note, the first peak comes from the crosstalk between transmitter and receiver, as we have in full duplex communication. And this also can degrade the radar performances. And so we can also optimize the waveform such that the compression doesn't affect too much the dynamic of the radar. So here, the key message is really to see that with waveform optimization, we can use the same hardware as in communication and achieve very high dynamic to be able to see small obstacles. And next slide, please. So on the previous slide, we saw the performance in range to be able to detect small target at high range, but you also want to use the same radar for angular domain processing. And in radar, we can use the concept of virtual array, such that if the receiver is able to separate the signal coming from each transmitter, we can synthesize what we call a virtual array, which contains more antennas than the physical element. So in this figure, we see that if you have 4 transmit antennas and 4 receive antennas, we can in fact synthesize a virtual array which contains 16 elements. And that is used to achieve high angular resolution. But in our case, it's not enough because we target a resolution of 6 degrees and we don't have a lot of antennas. That's why we also investigate super resolution algorithm such as music to be able to achieve a higher resolution with a limited number of antennas. And here the change is really comes from the fact that we don't have a lot of physical elements, but we still want to achieve a high angular resolution. So that was the end of my part.
Thank you very much, Mark. And many thanks to all our presenters. That concludes the part of the SNS for the second slot. So I would like to hand over to the colleague from 5G-ACIA, Ate Lancisalmi, the president of Work Group 3 chair. Please, Ate, the floor is yours.
Costas, sorry, I joined late. I don't know if we get to present the ISAC project.
No, no possibility, Dan. There was nobody, but we indicated to the colleagues that the material will be your presentation will be in the material. You know that will be made public, available, and that the colleagues may contact you directly for interaction. So thanks, Dan. Yeah, we try to reach you, but no problem. But thanks for joining. Now, thanks.
Ate, please, yours.
All right. Thank you very much. I hope you can hear me, see me, and see my slides.
Yes, all good.
Good. Yeah, it's been a while since I've been using WebEx, and I'm relying on the browser. I don't have the application, but happy to hear that everything is good. So thank you for the invitation. It's a pleasure to be here. I'm the Working Group 3 chairman from 5G-ACIA. Nokia is my company, and I will be talking about sensing-assisted positioning in this working group. And just to get us going, let me remind you about the working group in the organization. Afif already showed earlier the organization of 5G-ACIA, and I think the first webinar was probably looking into this in a more detailed level. But let me just state that this is the system architecture and integration aspects working group. In one way, it's like the SA2 of 5G-ACIA, if you think in terms of 3GPP. So we're looking into things at that level. However, 5G-ACIA obviously is not a standard setting organization. It's not a research organization either. We are an industry engagement organization, an alliance between the OT and ICT companies. And I'd like to stress the integration aspect here. So our task is to discuss topics that are of interest to the, let's say, end users of industrial 5G and the integrators and companies in that space. So it's not an ICT only organization. I'm sure you understand that already, but I really want to stress on that. And I've had the pleasure to work here for the last 6 years that 5G-ACIA has been in existence, and the working group is led by myself and colleague from Ericsson, Ahmad. You can see his picture here as well. And just to continue a little bit on the context, here is a list of recent white papers that we have been working on in Working Group 3, and they have already been published. The link to all white papers is here on the slide, but just to highlight that we have worked on RedCap, TETNet, that are sort of 5G features that offer capabilities for industrial domains. So they are coming in from the ICT side. Machine vision and OPC UA are more coming from the OT side and presenting things that are important for them. And we are discussing how those work with 5G. Of course, NPNs for industrial scenarios, the last document here, is more ICT oriented or driven, if you will, but it really brings together both of these aspects. And as has been stated, we have this recently started white paper on integrated sensing and communication, sensing-assisted positioning being the main scope of that, and I will get to that in just a minute. First, I'd like to remind you of the importance of positioning. I'm pretty sure everybody understands this, because somehow sensing, to me, not being a sensing expert, is all about positioning location of something, the environment or the things in the environment. And positioning, if we just look at that and consider that as something that the communication device, like 5G device, also has this capability of being positioned, that is a key component for digital twinning the environment. And that's important because in the purpose of doing digital twinning is to be able to run the systems in the computer world or in the cloud, and you do that to be able to optimize things. And that's sort of the central concept of Industry 4.0, and all of this fits very well to that. I think Industry 4.0 might not be a sexy title to put on anything these days, but it's still what we are essentially talking about. It's very important to allow this, because you can't do the optimizations alone in the physical world. You have to put everything into the computers and let them do that. And we all understand that, I'm sure. And of course, with positioning, it's a physical world thing. There are other things like being able to assure that security is in place. You're not losing your assets by somebody stealing them, or other things like being able to prove for legal concept where things are and where they aren't. So this is a very, very central concept that is needed, and any communication system that we would offer for industrial domain in particular should be able to do positioning as part of it. If we claim that it's a multi-use case system, such as what we have done for 5G and what 6G will be. And of course, we have had positioning included in already in previous generations. So that is a no-brainer as such. All right. Then finally about this new work item that we have started, and I have to come in with a disclaimer because 5G-ACIA work is not public until it's publicized. So this is merely a sort of teaser text that I can present to you. So we have an agreement that we have working piece inside 5G-ACIA, and we only publish the idea of the work items in front. So, but what I can tell you is that yes, we are talking about sensing assisted positioning. It will be a white paper. We are taking it slowly and carefully, and we'll be working all through the year 26 to complete the content. The publication is probably going to only happen in March 27. And here we, of course, discuss multiple aspects of sensing and positioning technologies. So we need to explain this to our readers, because the readers are not the ICT researchers or even the telco companies. We have many companies from the industrial operational technologies domain that are not experts in any of this. So we have to start from there. And of course, the main purpose of this work is to present how sensing can be used to improve positioning and discuss the potential of its, what are the applications of it in industrial domain. That really is the main purpose here. And it will be an interesting discussion with you in the research side. We'll be tapping onto your results. And I'm sure many of you are interested in hearing also what the industrial domain thinks of all of this. And my sort of advice or the beginning speech for this work item, as well as many others, is that is the realization we had already a while ago in 5G-ACIA that the requirements that were originally presented for 5G from industrial domain, they are those that really prevail going on into 6G, and there are only basically a couple of things that 6G adds, and those were those things that you already showed in the earlier 6G slide. So sensing is a key new technology that comes in, as well as AI, of course. AI is everywhere nowadays. The challenge is not only to add sensing to help, for instance, positioning technologies. The challenge is to do that in a way that is economical and feasible for the implementations, and that basically means that it needs to be done in a simple way, and I can exemplify that by saying that if the technology is not in the consumer devices, if it's a niche thing that would be applicable only for certain industrial segment, it will never make it to the chipsets. So that's that's my final advice. And I think Didier, you want me to already close, and that was indeed my last slide. So thank you.
Thank you so much, Ate, and yeah, for bringing forward some very real concerns about the implementation, not just the research for the sake of it. But you're absolutely right. What we work on should have a realistic chance of landing in the market. Many thanks to all the speakers. We've actually done very good timing. We do have a couple of minutes for questions in case there are some right now. I'm checking the chat. I don't see any specific question for
there is
the
one.
speakers.
Yeah, there is one from Jens. I think Jens maybe from City Mesh, if I. But there is one from Jens on this question of implementation. So it's a bit what has been tackled also by Ate and colleagues. But in terms of concrete implementation as of today, use case, business case related to ISAC and JCAS. So I don't know if we have heard already some points. And work is going towards standardization, and the question of the business case is crucial. But I don't know if someone from live, we can also address in the session 3, but if someone would like to start covering the point from Jens. Beyond that, I don't see indeed, Kostas, I don't see additional direct question. Again, as explained, if you want to, when you will have the material, if you want to raise also question to the different speakers, don't hesitate to contact them directly, including Dan for Ecoinet, who could not join session 1. Someone wants to tackle the point from Jens, or Jens, you would like to express briefly before we go to session 3? No, I don't know if you can hear me, Jens, if you're still there, by the way, the participants. No. Okay, no, Kostas, in this case,
okay.
let's move.
Please, let's move ahead to the sessions.
Okay, thanks. Yeah, Alex. Yeah. Thanks,
so, Alex.
Yeah.
Floor is yours.
Thank you. Let me try to share my screen. And if I manage to share also the slides. Interesting. Apologies for this. Okay. Hopefully you can see the slides now. Correct?
Yes, all good.
Okay, thank you very much. Okay, so very interesting presentation so far. Many thanks to all the speakers. Just to echo what Ate was saying, that indeed this is one of the hot topics for 6G, with the significant prospects for monetization. Of course, these statements have to be verified during the next few years. But it's excellent that we see that there are commonalities and that between the 5G-ACIA and the SNS world, and it's really nice and excellent presentation from the SNS projects, already delivering some very important results. Having said that, the third session is about standardization and impact. This is standardization and impact is one of the key, let's call it KPI at the programmatic level for the SNS JU. So we will listen to the following speakers from the SNS projects, what they have achieved or what challenges they have faced so far. Simply to say that in terms of impact, just a teaser with the results that are by the end of 2024. So we are doing this exercise yearly, so the numbers are already significantly higher. In terms of events or publication, you can see that we have 91 patent applications from the SNSJU projects, a huge number of test and trials, as well as, I would also say here, the number of open source solutions that the SNSJU community is producing. And of course, the contribution to the standards, which by the end of 2024, it was already at more than 1,000 contributions. Now, without any further delay, because this session is quite loaded, Sebastian, you are the first speaker from MultiX.
Yes, sorry, just trying to find
Yeah, it's on mute, of course. You have the floor.
Yes, thank you so much. So yeah, if you can go to the next slide, please. So MultiX, the methodology we are following for standardization, given that it's one of the core objectives of the call within which we receive the funding, is to really implement the European Commission's Code of Practice on standardization, meaning in particular for the the non-industry organizations to not only go after peer-reviewed scientific publications, but also try to impact, in particular, pre-standardization SDOs. So we also have the methodology as part of this to be addressed and adhere to GDPR, AI Act, as well as Data Act code of practices and the requirements to address this in terms of realizing technologies to adhere to it. We, as a project, have formed a standardization advisory committee, which basically allows us to assess any sort of innovation we are developing from the perspective of a standard. We have the individuals from, you see a list of organizations here, and those individuals are really actively monitoring and participating in SDOs, so 3GPP, IETF, and GMN, ETSI, ORAN, you name it. And we are really trying to always steer the conversation within the project. Now, the ultimate goal, what we're trying to achieve on top of us as individual organizations as part of Multi-X, is to actually form some sort of interest group within the pre-standardization working group on the topic of ISAC as one of the 3 IMT 2030 or usage scenarios that are new for the 2030 vision. And this sort of interest group ideally should be allow all our projects to form some sort of opinion and share experiences when it comes to standardization and see perhaps where we can align a bit our views, not to say even potentially co-signing and certain contributions. And if you can go to the next slide, which actually demonstrates already the impact we can make. So remember, Multi-X is now in month 10. So we're already on the left, and something, the top line was missing. So at the left, you see the number of contributions per SDO. So in ETSI, we had 36 contributions already, which is the ISAC ISG. So it's pure 6G. 3GPP, we have 11 contributions, all on ISAC, both 6G as well as the 5G advanced. And IETF, we have 4 on the right. You see the adopted ones. So we have in ETSI 16 adopted TDocs that really have proposed solutions, key issues on ISAC for 6G. And in 3GPP, it's a mix of 5G advanced proposed solutions within the study item, and as well as the 6G study item on 6G architecture, where we also see contributions, as well as also 6G use cases from Multi-X partners that got accepted as they won at the meeting in Sweden. And that's all from us. Thank you.
Very interesting results, and congrats for your impact that you are already having. Let's move on to the next speaker, Kyriako.
Hello, my name is Kyriakos Stylianopoulos, and I'm representing 6G ISAC, giving a distributed aspect in the ISAC domain. If we go to the next slide. Yes, the project is at a very a nice position to transfer its results from the academia to the industry, being between TRL 2 and TRL 5, which means that we're starting to move our implementations from lab demonstrations to proper field trials. And the goals of the campaign in terms of standardization is to ensure that our results are actually usable by the industry, because we have a lot of academics that don't necessarily are not aligned to how the industry uses the results. And that way, through the standardization, through the guidance of the academic partners, we want to enhance the industrial exploitation of the stakeholder value of the results. So we are participating in multiple SDOs. The principal ones is the HCISGs, particularly ISAC and a little bit of RAS. And we are also focusing in 3GPP, especially in the Iran and the SA TSGs. And if we go to the next slide. So our contributions, which gives a flavor of what we're doing in the project, are as follows. For in the ISAC, the standardization body, we have been preoccupied with how sensing data are represented, processing, and are computing between different nodes, which is an important avenue when we are going distributed in ISAC. And we're also involved in the RIS-ISG, Reconfigurable Intelligence Services, because we kind of need a lot of devices and low-cost devices, so RASs are a factor. And in terms of the RAN and the SA working groups under 3GPP, our involvement has been mostly in use cases and scenarios and how to apply them under 6G and ISAC, as well as how to enhance the functionalities in terms of sensing, for example, how to do authorization, configuration, and other discoveries of entities, and how the overall architecture and encompass heterogeneous devices and other similar functionalities. And that's it from my side.
Again, congrats to you, Stelion. You are having a very good coverage. Let's move on to the next one project, 6G Musical. Is that?
Thank you very much. It's me again. Next slide, please. So effectively, we are members, founding members of the ISAC industry specification group of ETSI. And we have been very active in this. Specifically, we have submitted several papers, effectively looking at the security issues in all the ISAC scenarios defined by ETSI, the ISAC, ISAC ISG. And you can think of two problems of security. One of them is when the ISAC signaling itself is used by the target for data eavesdropping, so to basically detect the information itself. Or the second possibility is when the ISAC infrastructure itself is used for unauthorized sensing, so sensing of location of connected or unconnected objects, which is unauthorized, finding a location of someone unauthorized. And for that, we have submitted a set of papers, and we're hoping that these will be taken on board for future industry specifications and future ETSI specifications. All the work is still reasonably new. The ISAC ISG is only about 18 months old, if I remember correctly. That's all I want to say.
Okay, thank you very much, and well done for already feeding ETSI with a number of contributions from the project. Very nice. 6G reference with Stefan.
Hello, yes, my name is Stefan Andersson and I'm working for Ericsson, and I will present the view here from 6G reference. So next slide, please. So I will talk about the standardization challenges that we've seen in those projects and also how we intend to generate impact from our side. Starting with the challenges, I mean, I'm sure you all know that standardization doesn't only depend on the excellent research we all do in those EU projects, but it's also very much about industry consensus and regulation. And that's very much outside the scope and control of those single projects. And that's what we must have in mind. So that means that for small projects like our project, 6G reference, I mean, we do have a limited direct influence. So we think that the way to success here really relies on engaging with the standardization delegates from partner companies, and that we should have those companies in each of those projects. It's also so that even if we work on something on a research level, it may not be ready for standardization during the project time as well. So it's important that we also have those companies that can continue with this and keep those ideas to use with the right timing when it comes to standardization. When it comes to the expected contribution from an impact from 6G reference, our main mission here is to provide hardware realism, as we call it, to the standardization work, to ensure that we can implement new features at a reasonable cost, at a reasonable power consumption, because if we can't do that, it's not very likely that those new features actually will come into play. We also work a lot to provide innovations, patents, to really have realistic hardware insights. And finally, I would also like to stress that demonstrators with real hardware, that really builds confidence in what we do. And I'm not saying we shouldn't do simulations, absolutely, we should. But there are things that we may not capture if we only rely on simulations. So really work with hardware to build confidence in what we implement. And I think that concludes my talk.
Stefan, thank you very much. I can only say that I fully subscribe with what you said about standardization and the challenges, and what are the expectations from projects. We see that there are some projects already that they are providing things, but standardization is a very important topic for the industry, and the SNSJU is an industry-driven area. So I have nothing more to add to what you said. I fully subscribe to your statements, and I will pass now the floor to my colleague Michael Barr, who is the working group 1 chairman of the 5G-ACIA. And Michael, you have the floor. I see that you are muted, Michael. Can you hear us?
Thank you very much. I had some problem with the
controls.
First, I have to excuse this nice, very static video of mine, but my audio should be fine now.
The audio is fine, yeah.
The camera just decided to have a break. And then let's start with the slides.
We can see the slides. You have the floor.
Okay, thank you. So you may see several things which are similar to projects in standardization. Some things are different for 5G-ACIA, but we are engaged in standardization. We have connections or collaborate with several partners like 6G, SNS, IA, which is today, but also with 3GPP and other standard organizations and standard-related organizations. What I would like to add here is that 5G-ACIA has been a 3GPP market representation partner since 2018, since the beginning, representing the perspectives of the industrial domain towards 3GPP. And of course, we collaborate in different means like MOUs, cooperation agreements with these cooperation partners, but also liaison statements where applicable and common presentations and so on. And coming to one specific work where I would like to focus on, I'm the rapporteur of a work item called 3GPP SA1 supports related to 5G-ACIA use cases, requirements, and KPIs. That's the work item which is, the target is to support our impact on standardization with respect to use cases and requirements and set the basis and the start for any standardization work. And the concept is to provide a discussion forum where for instance, 3GPP members can provide their contributions and get feedback from non-3GPP members within 5G-ACIA, also to provide those non-3GPP members the chance to provide their input to 3GPP contributions, and also to take some pressure off from the 3GPP meetings in order to have relevant discussions done beforehand, so that we have a higher chance of approval of these contributions. It is a voluntary activity, so there is no KPI on number of standard contributions, but of course, the 5G-ACIA has a business interest in getting things into standardization and having the vision also implemented, vision of 5G-ACIA and industrial 5G also implemented in standardizations and standards and specifications. And similar to projects in standardization, 5G-ACIA is not a member in many standardization organizations. So in the end, the responsibility for the contributions is with the individual members from 5G-ACIA, with the individual 3GPP members, which are also 5G-ACIA members. So we, besides these discussion of contributions ones, especially for 3GPP, we also work on 5G-ACIA content, which is directly sent to standardization organizations. So 3GPP had a series of workshops on 6G, where also the MRPs were invited to present. So we prepared these presentations for 5G-ACIA for the use cases and also on the general 6G workshop in March this year. You can find here the links. Also for the ITUR work on the minimum requirements for IMT 2030, we provided a contribution as well. And of course, we react to any request or any communication by other standardization organizations or partners, like, for instance, like your request of draft versions of specifications or other things. One more thing I would like to mention with how we try to influence and shape standardization is through liaison statements. That's a general activity of 5G-ACIA, and this is usually done by any working group that has an interest in doing such a liaison statement. Usually the group who did the work also provides this liaison statement. We use it for announcing white papers, for instance, at the ISAC, we announced our white paper you heard in session 1, but also to communicate certain white papers, information, issues, or other things to 3GPP, to raise topics with standardization organizations. Here you have 2 examples which we sent to 3GPP on the integrated sensing communication use cases and requirements, but also on some proposed enhancements for the 5G system operating as a logical TSN bridge in integrated network. And last but not least, I would simply show you a slide from our 6G workshop presentation. Since we are here to talk about integrated sensing communication, this is what we showed here on ISAC. Of course, we mentioned here our use cases we identified, and there we see an application of ISAC, and also the potential advantages in order to motivate standardization work on this topic. What I would also like to mention at the beginning, I mentioned this discussion forum. So for instance, we also discussed the multi-X contributions to SA1, the 2 multi-X contributions that had relation to industrial use cases. So we had already some connection to the 6G FNS projects. And with that, I would like to thank you, and I hope it's still in time.
Yes, indeed. I think that we have managed quite nicely this session so far. I have checked for comments, but I haven't seen anything. So Didier, we may start preparing for the last session and the closing. Actually, 2 hours is maybe a little bit too much. Simply to say, before I give you back the floor, that standardization for the SNS projects is, as I said, quite important. With all the asterisks that we have already indicated. But Kostas, for example, as the TB chairman, he is doing several activities to inform the projects on how, and especially organizations that are not very familiar with the standardization process, to see if there are opportunities and how they can address this. We will also plan for webinars to try to disseminate about opportunities in the process for standardization to our stakeholders, so that we can boost the European participation in this kind of activities. And with that, Didier, I give you back the floor.
No, thanks a lot. Thanks a lot, Alex and colleagues. Indeed, again, an excellent session 3. So it's now time, to wrap up and to conclude. So I will call back Raffaele and Afif for the conclusion, and then at the end I will show you one last slide for the perspective for next year, possible development of synergies between SNS 6G-IA and 5G-ACIA and broader. So please, Raffaele, if you'd like to bring your points and share, and then we will listen carefully also to Afif. Can you hear us, Raffaele?
Sorry, I was on mute.
No, please.
Okay. No, thank you. I will just provide some words for conclusions. First of all, thanks, Didier, for organizing this very interesting workshop. From my point of view, ISAC is something very interesting, since from my point of view, it provides a clear differentiator with respect to 5G. So this is, I guess, an opportunity, first of all, for vertical industries, since it provides new use cases and provides some societal benefits also. We have seen today, for instance, that ISAC may enhance labor safety in manufacturing, but this is not the only feature that ISAC has. As an industry representative, I hope, of course, that ISAC will provide also new ways of monetizing our infrastructure, so 6G in the future, which we need. And I don't have further things to say. I think that there will be a follow-up of this workshop in the spring 2026. We are organizing a 6G-IA also workshop during 5G Territory in Riga on October 22nd. So this will be a further opportunity to drill down on ISAC. And thank you also on behalf of the 6G-IA board, and I leave the floor to Afif.
Thank you. Thanks, Raphael. Afif?
Yeah, many thanks as well. I mean, to all the speakers from both sides. Really very interesting. I would like to make, I mean, some comments from 5G-ACIA, from 5G-ACIA's perspective. I understand, of course, 6G-IA and SNS, you are working on long term on 6G. If I speak from 5G-ACIA's perspective, we are interested as well, as mentioned, on short term, on realistic solutions and cost-efficient ones in terms of complexity. And we actually, some of the players will say, we don't want to wait until 6G standard is ready, isn't it? Then it will be too late. I mean, this is another important dimension to keep in mind. And listening to 6G musical references, etc., I think there are exciting ideas about architecture, new architecture, newer interfaces where you, if you want really, I mean, those two aspects integrated as in communication. But keep in mind, from industrial settings, we cannot really wait for a long time. It's important that to design solutions which are feasible within the 6G, 5G context as well. For example, when Hao-Min Chao, I mean, he mentioned some of the use cases, human-machine interaction, etc. These are real use cases in a factory and or on process as well, industries. And it's important for those industries that you can come back with solutions that also does not require drastic and dramatic change on the short term. Some of them, of course, it's okay. I mean, if it's a long term, but remember that those players will not wait till 6G in 2030 or 2035. It will be too late. And keep in mind that it has to work. I mean, at least the big bulk was 5G. So this is what I had basically in mind, and I would like to say it's not only about sensing. We do an ISAC and 5G-ACIA. It's much broader. It has been shown and mentioned both by Michel Bar and Ate as well. And we are really happy to have this dialogue and interaction. Thanks in particular for you, Didier, for pushing it, I mean, every time.
Thanks a lot, Afif. Very good feedback indeed, and thanks for positive. And it's a very, very great teamwork. I'd like to, because we're going to conclude now, so I'd like to show you just one last slide, and I will pass in full screen. Oops, yeah, just in terms of perspective, and also to take this opportunity. Indeed, we had, I think, up to 94 live participants. So again, the material, video will be made publicly available. So do not hesitate to encourage your colleagues to potentially also review. I'd like to thank all the champions, all the project representatives, all the 5G-ACIA colleagues. I think these are really extremely good work and development that are done on both in both association and in the program and the project in terms of research innovation. As you mentioned, Afif, what is interesting also to see is what is developed, what is tested and concretely deployed, implemented, validated on both community with different test bed and the trials and pilots on both sides. So the idea, indeed, and what we where we go a bit more in depth now and organizing this joint session, this joint webinar is really to develop the synergy and boost and accelerate. So this is a key message. So we are very happy about this webinar. So the idea is let's see and let's further investigate, because for the time being, there is no publication from SNS and 6G-IA on ISAC and JCAS. And we were thinking more clearly, there is this good paper that has been started from SNS perspective on industry vertical with Niels. Niels from Fraunhofer is chairing, leading this white paper work, and we know how Niels is also involved in 5G-ACIA, and Niels and the colleagues involved in Target X, so really at the junction of both communities. So it's good. Let's see if we can make also potentially a combined work. Just to spot it, this is work in progress. So I see that Pavlos was also connected, but very briefly, as you may know, we are developing. It's in draft stage. Some of you have answered to the consultation that has been organized over summer for the SNS Work Program 2026. There would be a priori still all of that under confirmation. It's not completed, but a strand 5 on experimental infrastructure, trying to experiment and to work on the further development on infrastructure for SNS and experimenting specific enablers and technologies, if you know SNS, so basically in direct connection also with the Stream B project. And just to mention that ISAC JCAS is one of the 6 technologies that is identified. So just to raise this, we have time. If confirmed and when it will be launched, if confirmed deadline in April 26, there may be also opportunity to further explore ISAC also in the context of the work program 2026. So as mentioned by Raphael Afif, clearly this is not the end of the story. So we are planning further webinars jointly organized next year, maybe 2. We really stick, it's a very good idea, to the schedule from 5G-ACIA colleagues, the 10th of the month. So it's a good idea. So it's good to remind also to remember 10th of the month. So let's see next year. And then also an invitation, some of you, clearly we had the opportunity, nothing replaces the face-to-face, we know, to meet in Poznan during EOCNC and 6G Summit. This is tier 1 conference in Europe on 6G for research innovation. So really, let's try to see how we can exploit the Malaga opportunity. Several of us, we are also in the steering committee organization of EOCNC. So it may be also an opportunity. So I'd like to close here to thank also all the participants, all the audience. And I will not forget to thank all the colleagues who contribute to work with us for the logistics, and the support. So I hope I'm sure I will forget some of the names, but please apologize for this if I forget. But Julia, Jackie, Tina, the colleagues who are also supporting and communicating and making this possible also in terms of relaying from 5G-ACIA perspective, and Audrey, Valeria, Veronica, Ludgard, Carol, and other colleagues. So thanks to all of you, and I propose to close here. And now stay tuned. We're gonna, I think it will come maybe from Alex or Costas. We're gonna inform and relay as soon as everything is uploaded on the webpage, on the website. So see you soon, see you next time, and I propose to stop now this webinar. Ludgard, you can stop the recording. Thanks a lot. See you next time. Thank you. Bye-bye.
Thank you very much.
Thank you.